Okay, right. So I'm going to create a video on this demonstration about levers and looking at the load and the effort. Now, if you imagine a wheelbarrow, when you carry the wheelbarrow, you want as least effort so you can carry a bigger load. Makes sense, okay? So as a starting point, I've got load over here, effort over here, and then we've got our table data, and you're going to complete that as we go along. So on our load, we've got our force. Now, each one of these is 10 grams. So the 10 grams to newtons is 0.0981. So if we round it off, we get 0.1 newton. So as a force, each one of these is worth 0.1 newton. Now, so the load, we're going to put the load onto 1 centimetre away. Okay, now for demonstration purposes, so this is obviously not a centimetre, but we're just going to call it centimetre. If I put a rule on it, it'd be about 4 centimetres. But just to keep it simplistic for the demo, we're going to say it's 1 centimetre. So, put it onto the 2. Now, I've got one of these. Okay, so if I put that onto the 1, and that's 1, the load and the effort, and they're equal, then you're not going to get what we're after. Okay, there's not enough effort. So, if we increase the distance away from the pivot point, okay, nice and gently as well, so I'm just going to use my pencil. You can see it's starting to, he says. Okay, so we've just got a little balance there. Okay, so I'm just going to, so it goes too far, there you go, it's going to go too far now. I'm just going to put that back there, and then just gently try and balance it. Okay, right, we've got that balance, so I'm going to leave that there. Now, if we talk about the science, so the distance from this point, from the pivot point to that point is 1. I've just knocked it. And then from that point is 2. Okay, so you've got a greater distance. Now, the greater distance is allowing the effort to be less than the actual load. Okay, and that's what we would want to achieve with our simple machine. Okay. So, in terms of filling in, we've got 0.2, 2 of them, 0.2 newtons, 1 centimetre, 0.1, and a distance of 2. Okay. Now, what we're going to do next time, we're going to use still 0.2, but we're going to change the distance to 2. So we're going to go 2 on here, like so. Okay. And here we've got 0.1, we're going to go to 4. Okay, so again, I'm just going to try and get that point of balance. It's not easy, but you can see now that's just starting to balance. Okay, so if I take any further, I might just lose it. Okay, so that's about as good as I'm going to get. So if we look at the numbers, so we've gone on the load, we've gone to 2 centimeters. From the 0, if we come out, it's gone to 4. Okay. So we've got 2 and we've got 1 force, as in the mass. Okay, so the mass is converted into a force, and it's doubled. Okay, so the distance has doubled, and the key thing to take from it is that as you increase the distance, it's less effort. Okay, so we're going to do one more, and we've got 0.2 again, and now we're going to go 3 centimeters. I'm going to push that onto 3, and we've got here a force of 0.1 newtons again. So we're going to see how far. Now, prediction wise, if I'm on 3 centimeters, how far distance from the pivot point do you think it will need to be? Let's see. Don't prove me wrong. Okay, so again, it's difficult, but you can see around the 6 centimeter mark. So it's kind of double again. And nearly there, nearly there, nearly there. Okay, so that's balanced. Okay. Right, so in terms of our numbers then, so we've got 3 and we've got a 6, and we can do the calculation to work out the work done. Now we're going to go to 0.3 on the 1, so we're putting that one onto there, and we're going to see, so I'm going with 1 again. So if that's on the 1, I'm going to start off with 2 and expect that to go. Now because you've got 3 times the weight on that one there, if I push that to the 3, that should be around my balance point. Okay, now you know you've got a big load and you've got big distance on the effort side, and you can see how that's working. Okay, so on here that would be, you know, if I was going to fill it in, that would be 3. I'll do that now. And so we're going to go, so I've got 0, so we'll stay on the 0.3, and I'm going to move the load to 2, distance of 2, so 0.3, distance of 2, and I'm going to predict, so I've got 3, so I'm possibly going to want to go as far as 6. Let's see how that works. So big distance. Oh, perfect. Okay, so it's a little bit more than 6, but you know, I'm not, you know, it's proving the point. So big distance, I've only got one of them, I've got 3 there. So bigger load, big distance, you get it balanced. So you're reducing the effort. Now, in terms of your calculations, so if I've got work done, so work done is equal to the force times distance. I would then have, so my force, so I'll put my force is 0.2, I then times by the 1, okay, as an example, and you just complete the calculation. So the next one would be 0.2, times it by the 2, equals, find out the answer, okay.